Investigation of light emitting diode wavelength effect on optical component molded from polycarbonate resin. This is presented by Daniel McMaster and Noah Morningstar, sponsored by Clariance Technologies and Trucklight, and advised by Dr. Gamini Mendis. Clariance Technology presented us with a project where a deposit was found on an old series headlamp, and we're asked to find a solution and characterize the deposit formation. We expect the Vistex 111-50 anti-fog coating to reduce the hazing measured by light intensity output, but will not resolve the deposit issue. Coatings are used to help prevent common failure modes like yellowing, fogging, or hazing, and we believe the Vistex 111-50 will be a better contrast compared to the HMDSO that is currently used.
To test this, we performed a burn-in test where we exposed the headlights to 2,500 hours of burn-in. And then to test the light intensity output before and after burn-in, we tested this using the Gamini photometer. And to characterize the deposit formed on the lenses, we used NMR. Taking a look at our weekly measurements, Figure 3 shows the deposit formed on the Momentive HMDSO lenses within the first week. The spectrophotometer data showed no significant change over the course of the burn-in due to the spectrum ranging from -128 to 128 and our values being very low. And the temperature measurements also being insignificant due to their temperatures being nowhere near the material or coating morphology points. Looking at our Gamini photometer results, Figure 5 shows the Gamini photometer data broken into pre and post burn-in for high and low beam. And the significant takeaway from this is the Momentive HMDSO lenses showed the biggest decrease in light intensity output with a 57% high beam and 89% low beam decrease.
The NMR results show significant changes seen in the Momentive HMDSO and our blank samples. This can be seen in amide groups found at 7.8 ppm, and then alkene and alcohol functional groups are found at 3.5 and 4.5 ppm. The closest structure we found to this is a polyurethane acrylate, which is found on either the polycarbonate and or the coating applied surface. So to conclude, the Vistex 111-50 did provide substantial visual improvement by improving in light intensity output by post-burn-in of 77% in the NMR. And NMR will need professional analysis to further interpret the structure and degradation mechanism. We'd like to thank Dr. Mendoz, our advisor, Dr. Zhang, Mr. Vitelli, Dr. Dillon, our graders, Roger Elmer, who was a representative from the sponsor, and Erica Mack and John Foster, who helped us throughout the project.